Hello and welcome you guys to my new awesome video about the Theorem of Pythagoras. What is the Theorem of Pythagoras? I will start off with drawing a triangle. There's something very important about the triangle, that we have a 90-degree angle here. I will give here the sides A, B, C. These are the corners, A, B, and C. Okay, and actually what the big statement is of the Theorem of Pythagoras is that A squared, which is a leg of this triangle, plus B squared is equal to C squared. Okay, this is the big thing that we want to prove in going through our steps. And how did Pythagoras prove this? The first thing he did was he draw here the height of that triangle. I hope it's a little bit right. And here we have again a 90-degree angle, okay? Now there's an important part. These parts from C, okay, this whole length is divided into two parts. I will give them special names like P and Q. Actually, what P and Q are, you can think of them as a projection of the leg to the hypotenuse. Okay, imagine yourself a light here, and then this would be the shadow of B, and this is the shadow of Q. Okay, this is very important to keep that in mind as the shadow. Okay, now with dividing this thing up into two triangles, so by doing this height thing here, we have two triangles, and on that we have the big triangle. Okay, I will draw them in here as parts. Okay, and the other part is this. Here we have A, here we have Q, here we have P, here we have B. Okay, and actually this is the height in both of them. Now what Pythagoras did was he saw something very important. He saw, so if I give here angles here, this is alpha, this is beta, and this is known as to be 90 degrees, then what he saw here was that this, in the small angle, okay, or not small angle, but in the small triangle, this angle alpha and this angle of 90 degree will determine this side. This angle has to have a value of beta, because if you add all of them together, so 90 degrees plus alpha plus this, you will get 180. And actually this is the same as in the big triangle. So these are, this small triangle and the big one are related to each other, okay? And this is the same for this small triangle as this is alpha, okay? Same idea, 90 degrees beta, so the other angle has to be alpha. And so it seems that these triangles are very, very similar to each other. Now, what did Pythagoras do? What he said, first of all, was he looked at these triangles. And if you know about triangles that are similar to each other, then you could actually think of them lying like this. So this is the small triangle, let's say this. This is the big triangle, okay? Now what Pythagoras saw was there's some special theorem. I don't know how it's called in English, but actually it states that if you have lines that are two lines that are cut by parallel lines, then there are some relationships for the ratios of these sides, okay? Like this side divided with this side is the same ratio as this divided with the whole side here, okay? And this is what we want to do. We want to do this with this triangle. And if you look at this, then what we get is height. So this over P is equal, okay, now let's look at this triangle. Now we have to know the right roles. As the angle alpha is here, now we have the height takes the role of the P, and Q is here above, Q height. Now if we multiply with H and P, we get H squared is equal to P times Q. Okay, this is called the height theorem. Okay, now, okay, that was nice. What can we do further? The next step is we will do that with this triangle and the big one. Okay, we see that these are similar too, because alpha, beta, and 90 degrees, same angles. So what we can do actually is we can calculate the ratio of the hypotenuse with this leg, which is B over P, and this should be the same ratio of the hypotenuse to the belonging leg. Okay, so the hypotenuse in this big triangle is C, okay, and the leg belonging to that hypotenuse is B. So if we just multiply with B and P, we get B squared is equal to C times P. Okay? So this is what we got. And actually you can remember this formula as the lag theorem. And what it says is B squared is equal to C, the whole part of the side, and the projection of B actually, which is P here. Okay, now we can take our idea and compare this triangle now to the big again. And what we do here is we divide A over Q. Okay, now let's look at this. Okay, A was the hypotenuse. Let's look what is the hypotenuse here in this triangle. It's C, and Q was the side opposing to the angle alpha, which is here in the big triangle. It's A. Okay, and again we multiply with A and Q, and we get A squared is equal to C multiplied with Q. Okay, these are called leg theorems, so I'm just translating this from German to English. This is called height theorem. Now, actually what we wanted to end with was this. This is the theorem of Pythagoras, so we want to prove that. What we have to do for that one is we have to add, so if you look at these equations, they smell like Pythagoras. A squared, B squared, wow, why not add them up, both equations? So let's add them up. We get A squared on the left hand side plus B squared on the left hand side. So these both added, and we get the equal sign, and on the right hand side we get C times Q plus C times P. Okay, this is nice looking, okay, but still not Pythagoras. Pythagoras said it's equal to C squared. Okay, let's not stop at this point, but just see, well, we have C here and C here, so just factor this out. We get Q plus P. Wow, that looks nice. C times something. Actually, if this was equal to C, we would have A squared plus B squared equals C squared. And now let's look if this is true. If you look back into this triangle, then you see that C was the length, C, the hypotenuse, was divided into two parts, into P and Q. And if you add them up, you will end up having C again. So what we have here is C times C, or C squared. That actually completes our proof of the Pythagorean theorem. Sorry for my pen, it just stopped working. So I hope you can still see this, what we did. We just found out the leg theorems, we added them together, and we ended up in seeing that P plus Q is equal to C. Okay, I hope that explains you a little bit more about Pythagorean theorem, the most well-known theorem in mathematics. Okay, so I thank you for watching, and if you like my videos, please subscribe so you see every time I upload a new video. And that's it. See you guys. Have a nice day.